From this video, you can see baggage drop. Its function provides a dedicated area for passengers to drop off their checked luggage after completing self-check-in. Its purpose streamlines the check-in process by separating baggage drop-off from other check-in activities, reducing queues, wait times at traditional check-in counters. As you can see, this is self-check-in. It is functioned to allow passengers to check in for the flight without assistance from airline staff. Its purpose is to save time and provide convenience for passengers by enabling them to select seats, print boarding passes, and update personal details. So this is automated boarding gates. Gates equipped with self-service technology that facilitates the boarding process. Its purpose is to speed up boarding by allowing passengers to scan their boarding passes, verify their identities, and proceed onto the aircraft without manual intervention from gate agents. This enhances efficiency and reduces the likelihood of boarding delays.
Why are airport boarding gates important for passengers? Boarding gates are the designed entry points for passengers to access the aircraft. Passengers proceed through these gates to embark on their flight, making them a vital part of a departure process. Boarding gates are important for passengers for several reasons. Organization boarding gates help airport management organize the flow of passengers. Efficiency boarding and procedure reduce the waiting time and allow passengers to spend more time in relaxing. Safety gates contain signs and essential requirements in case of an emergency. Boarding process gates help the airline to identify and provide an efficient boarding process.
In the aviation safety security standards, as per the ICAO, it set the global standards for aviation security. Countries around the world have to follow these standards to maintain a consistent and high level of security across the aviation industry. Stringent security measures contribute to building public confidence and trust in air travel. Passengers are more likely to choose air transportation when they have confidence that appropriate measures are in place to ensure their safety. Aviation authorities and regulatory bodies mandate security measures to ensure compliance with national, international regulations. Non-compliance can result in severe penalties and restriction on an airport operations. Visible and effective security measures act as a deterrent to potential threats. Knowing that airports have robust security systems in place may discourage individuals or groups from attempting unlawful activities. As for the baggage screening, advanced X-ray scanners are used to examine the contents of passengers, check and carry on luggage. These scanners can detect a wide range of materials including explosive weapons and prohibited items, providing detailed images for security personnel to analyze. For the body scanners, millimeter wave scanner use non-ionization radiation to create a detailed three-dimensional image of a passenger body. These scanners can detect concealed items on the person without revealing anatomical details, enhancing privacy whilst ensuring security. Biometric identification technology is used at airports together with automated screening lanes to enhance security measures and streamline operation as well. Biometric identification systems use unique physical or behavioral characteristics such as fingerprints, facial recognition, iris scans, and voice recognition. This biometric data is shared with Interpol also for international watch lists. Biometric data is captured at various points in the airport including check-in, security, counter, and boarding gates. The data is then used to verify the passenger identity at each stage of the journey, eliminating the need for manual checks for boarding passes and photos, ensuring the safety of the passengers and also the efficient operation at the airport.
airport runway is a defined rectangular area on an airport where aircraft take off and land, and it is a crucial component of an airport infrastructure designed to accommodate the various types and size of aircraft that use the facility. Here are some key aspects of airport runways. The dimension of runways come in different length and width depending on the size and type of aircraft at the airport served. Larger airports typically have longer runways to accommodate commercial jet airliners. The surface of a runway is made of durable materials such as asphalt or concrete to withstand the weight and impact of landing aircraft. Some airports may also have grass or gravel runways, typically for smaller general aviation aircraft. Runway have specific markings and lighting system to guide pilots during takeoff and landing. These include runway centerline marking, threshold marking, and touchdown zone marking. Lighting systems such as runway edge light, threshold light, and approach light aid visibility during low light conditions. Runways are connected to taxiways, which are paved paths that allows aircraft to move between runways, terminal, hangar, and other airport facilities. Taxiways also connect runways to the apron where aircraft are parked. Many major runways are equipped with an ILS, a ground-based navigation system that provides precision guidance to pilots during the approach and landing phases, especially in low visibility conditions. These elements collectively contribute to the safe and efficient operation of aircraft at an airport. The design and construction of runways adhere to international standards set by the International Civil Aviation Organization, also known as ICAO. An air traffic control tower is a prominent component of an airport infrastructure, serving as a central hub for managing air traffic within the controlled airspace on the airport runway and taxiways. The primary function of an ATC tower include aircraft sequencing and separation, where ATC towers are responsible for ensuring the safe and efficient spacing between aircraft during takeoff, landing, and taxiing. These involve in providing clear instructions to pilots to maintain safe distance from other aircraft. The second function of ATC towers are for runway operations. The controllers inside the tower will manage the movement of aircraft on the runways, ensuring the safe departures and arrival of flight. They coordinated takeoff and landing and may issue clearance for taxiing to and from runways. ATC towers also facilitate in communication between air traffic controller and pilots. They use radio frequencies to provide instruction, clearance, and important information to pilots during various phases of flights. Another crucial function of ATC are to monitor local weather conditions from the tower to assess the impact on air traffic operation. This information is crucial for making decisions regarding runway in use, approach and departure procedures, and overall safety of the airport operation. ATC towers are staffed by air traffic controllers who work in a collaborative environment to ensure the safe and efficient movement of aircraft. Modern ATC towers often use advanced radar system, communication equipment, and automation tools to enhance their capabilities. Additionally, some airports may have multiple towers or radar facilities to manage different aspects of air traffic control, depending on the size and complexity of the aerodrome.